Hi, today we're solving problem 47. The first two consecutive numbers to have two distinct prime factors are 14 and 15. So 14 has prime factors 2 and 7, 15 has prime factors 3 and 5. The first three consecutive numbers to have three distinct prime factors are 644, 645, and 646, which have these prime factors. We need to find the first four consecutive integers to have four distinct prime factors. And what is the first of these four consecutive numbers? Now we can go ahead and start implementing this. What I'm going to do is I'm going to set a constant factor count, which for our problem is 4, but we're going to change this to test for the other cases. Now what do we want to do? We want to say, given all of the numbers with four distinct prime factors, we need to find a cluster of four consecutive of those numbers such that those four are also numerically consecutive. So what we want to do here is first calculate all of the numbers which have four prime factors. So I've copied the utility prime factors method, which gives us a list of all of the prime factors in a number. So what I'm going to do is I'm going to do val answer. What I'm going to do is I'm going to create an iterator from 1. Now the reason I'm creating an iterator here is, first, we don't know how long we want to search, and 2, we don't want to set a maximum limit because we may be searching too much then. So what I'm going to do with the iterator is I just keep on calculating values while I need to calculate them, because iterators are lazy, so we won't unnecessarily calculate any values. So we create this iterator from 1. We want to filter the values such that the number of distinct prime factors is our factor count. So I'm going to do util.primefactors for that number. We can pass an underscore here to fill in the blank there. Now prime factors is going to give us a list. And when we have a case such as 2 squared, the way we've implemented prime factors is it'll give us 2 2's. But we don't want to count those as two different prime factors. We want to remove all of the duplicates in our list. So what I'm going to do is I'm going to do dot distinct, which gives us the same list but with duplicates removed. And I need to check that the size of this is equal to the factor count. So now that we've filtered to check for all of the numbers which have four distinct prime factors, I need to find a cluster of those in the list that are numerically consecutive. So what I want to do is, first I want to find clusters of 4 numbers each. Now with an iterator or any Scala collection, that's super easy. I just use the sliding method, which takes how large of a sliding window we want to pass over our collection. So here now it'll give us the first 4 elements, then 4 elements starting from the second element, then 4 elements starting from the third element, and it'll just slide that window down. So it'll give us all of the 4 clusters within our iterator. Now given a iterator of given an iterator that we get from sliding, so now that we have each cluster of 4, what we need to do is check that the last element is, in the case of 4, 3 more than the first element. Because, for example, if you have 1, 2, 3, 4, we know that if we're given 1, 2, 3, and 4 in one group, we know that those are numerically consecutive because the last number is 3 more than the first number. And so we know that the 2 elements in between, which we know are going to be between the first and last, must be 2 and 3, because the total length is 4 and the difference between the first and last is 3. So what I'm going to do is I'm going to find such that, given the cluster here, the last element of the cluster minus the first element of the cluster, and to get the first we can use head, should be the factor count, which is how large we want our cluster to be, how large numerically consecutive of a cluster we want, and we subtract 1. So in this case it'll be 3, so we're checking that this cluster is numerically consecutive because we know the total size of our cluster is going to be our factor count, and that's actually something I missed out here. This should be factor count here because we want to use that constant instead of putting in magic numbers there. So we know that the size of the sequence is factor count, and we need to check now that they're numerically consecutive. Now that we've found this cluster, we need to get the value. So find returns us an option of what might be the value, just in case it doesn't find. But if it does find, we get back a sequence, and we care about the first element, so I'm going to do dot head on it. Now we can println our answer. We can go ahead and run it. And we get our answer. That's it for problem 47. I'll see you next time when you solve problem 48.